Okay, guys, in this video, I'm going to show you another example of finding curl of a vector field. Okay, so what you do is curl is sort of like finding the cross product, if you remember how we did that. So I drew this large determinant. It's very large because it's going to have a lot of terms. Now, just like we did for the cross product, the first row is going to be I, j, and k. Okay, the second row is going to be partial derivatives, but just notation for them, not partial derivative of something, but just partial derivative, which is kind of weird, but this is just a way to remember how to find curl. Okay, so these are partial derivatives, these letters like delta or whatever they are in Greek. Okay, and then the last row is actual vector field. So that's going to be x to the power 5z. And remember that you need to show me work. So this whole thing is not optional. You cannot just give me a final answer without showing me detailed work. And this is part of the work. Okay, so this is the last row. Now we're going to go ahead and compute the curl. So first, let's start with the ith component. So what are we going to do? Well, we're going to take this, remember, and multiply by that. That's usually what we do, right? Because what we do is we're just going to like cross out the row of the column where I is, and then we're like multiplying these guys together. But except in this case, you're not really multiplying. You're actually finding the derivative. So it may look like you're multiplying, but no, you're finding derivative with respect to y of 7xyz. Okay, so that's your first step. Okay, so what is the derivative of 7xyz with respect to y? So remember that 7x and z are just numbers and they are constant multiples, so we keep them. So derivative of number y is just the number. So in this case, it's going to be 7xz. Okay, then we're gonna subtract. Usually we say, okay, the product of the other ones, but again, this is not a product. In this case, you are actually applying the partial derivative with respect to z to this middle term. Okay, so what are you gonna do? So first, let's find the partial derivative of the e function with respect to z. Now, you may be tempted to say, oh, that's negative 8 e to the negative 8y. That would be incorrect because this term does not have a z. So terms that are added or subtracted that don't have the variable with respect to which you are taking the derivative of will drop out. So e to the negative 8y will disappear. Now, what about, so remember, we subtract the derivative. Okay, so we're going to subtract whatever we get right now. Why is this important? Because we're going to have a minus and a 2 and an x. Okay, because derivative of 2xz is 2x, because 2x is just a number, right? It's like number z. Okay, so that's going to be the ith component. Let's move to the jth component. Now remember that the jth component comes with a minus. Jth component comes with the minus, so remember that, okay? So let me just get rid of these lines if I can. And because I want to show you stuff. Ah, no, I didn't want to do that. That was too much. Just want to delete this and the shading. Okay, so now the jth component. So to find the jth component, we're gonna cross this out, right? And we're gonna multiply like this, right? Like that's the first one, and then this one, and subtract. Okay, but again, we're not really multiplying. We applying the derivative with respect to x to this term, the 7xyz. So when I apply derivative with respect to x, the other terms are just constant multiples, so I keep them. So it's going to be 7yz minus. Now this one with respect to z, well, x to the 5 is a number, right? Because it doesn't change when we're taking the derivative with respect to z. So this is like number z, and that's just going to be our number. So that will be x to the 5. Okay, finally, we're going to do the kth component. Okay, so let me just quickly move this thing actually over here, because we're now crossing out the last column and the first row. And then let me delete these now so we don't have that busy stuff here. So now we're going to take the derivative with respect to x of this term first and then subtract the other ones. So let's take the derivative with respect to x. Again, e to the negative 8y is added or subtracted and it doesn't have an x, so it's going to disappear and give you 0. The negative 2xz with respect to x, well, 2 and z are just numbers and they're constant multiples, so we keep them. So this is going to be minus 2z, right, with respect to x. Okay, then we're going to subtract the other one. Well, the other one you're going to be happy to find is going to be 0 because x to the 5 and z do not have a y, and they're just by itself. So this is like a number. What's derivative of a number? Well, 0. Okay, so now I'm ready to type it. So I'm going to get 7xz plus 2x. Here I'm going to actually distribute that minus to each term. And that's it.